All right, good afternoon, everyone. I hope everyone is well and that you enjoyed your weekend. Welcome back to Physical Science, where we are continuing our exploration of energy. In fact, today we are going to learn how to calculate kinetic and potential energy. So last week I introduced you to energy by introducing you to work, which is the definition of energy, the ability to do work. So we learned energy, the ability to do work. So we learned work being force times distance. We learned power being work over time. And I introduced you to mechanical energy at the end of the week and the conservation, there being the relationship or the sum of potential and kinetic energy. So I showed you the equation for potential and kinetic energy last week to give you an idea, a better idea of the concept based on the variables that were in the equation. Today, we're going to learn how to use the equations themselves. I'm not going to ask you to manipulate these two equations beyond solving for kinetic energy and solving for potential energy. So you won't have to solve for any other variable in the equation beyond these. Right? So kinetic energy is the energy of motion. And by definition, it is 1/2 times mass times velocity squared. And this is where you want to make sure that you pay attention to what you're doing with the equation. So mass for this is going to be in units, of kilograms. Velocity, which we know from our very beginning study, is meters per second. So we're looking for these variables in the equation. One of the ways that you may want to approach this, just to make sure you get this part correct, is you can just put in 0.5 times mass times velocity squared. It's a 5, not a 3. So again, you want to make sure that you square the velocity. So if you don't have a square button on your calculator or the calculator you're using on Chromebook, just multiply it by itself and then plug in that value. So then potential energy, which was based on height, gravitational pull, we had acceleration due to gravity, and height. So mass is in kilograms. Acceleration due to gravity is acceleration, so it's meters per second squared. And then height is in units of meters. All right. Then that just leaves what's the unit of energy, or the unit of kinetic and potential energy, or both joules. So I want to walk you through a couple of examples using the equation, and then walk you through the worksheets and exercises that I'd like for you to execute today. I'll find my example sheet here, of course. It has gotten buried. All right. So these are our equations. So again, the only variable that I'm going to ask you to solve for is kinetic energy, so you won't have to manipulate the equation for other variables. All right, so let's look at this question. What is the kinetic energy? So we're looking for KE. And I know that you don't like to list variables, but I'm going to require it until we show that our math execution improves a little on assessments. All right, so we're looking for kinetic energy. We have a 1,200 kilogram object. So kilograms tells me that that is mass. That is moving at a speed of 24 meters per second. So we know that our velocity is 24 meters per second. Our equation for kinetic energy, I'm going to plug it in like this. Mass times velocity squared. 1/2 mass times velocity squared. So when we plug in our values, we have to make sure certain, that's not squared. It's not acceleration, that's just velocity. Sorry about that. All right, so when we plug in our values like this, we're just going to multiply, we're going to square our velocity, and I want to encourage you to do that first. Square your velocity, and then you're just going to multiply it by the others. So I've made an error here. Do you recognize what it is? In my haste, I didn't put in the 0.5, actually. Let's rewrite that all together. Sorry about that. Because it's 1/2 mass times velocity squared. Okay, so when you plug this in, we get a very big number. The kinetic energy is equal to 345,600, and the unit of kinetic energy are joules. I'm going to do another example, number 7. And again, kinetic energy is the only variable in the equation I'm going to ask you to solve for. What is the kinetic energy? So that's what we're looking for. Of a 478 kilogram object. So that is mass. Moving with a speed of 15 meters per second. So get on the page, sorry. So kinetic energy is 0.5 times mass times velocity squared. So 0.5 times 478 times 15 squared. We plug all that in and we end up with another large number for our kinetic energy. Okay. So that is the use of the kinetic energy equation. Now I'd like to do a couple of examples of potential energy for you. All right. So I'm going to do one where they're just giving you the variables, and then I'm going to do one from the word problem. Say, look a little different. So in the sample, we know that we're looking for potential energy. They've already identified the variables, which makes it much easier, but of course life is not always like that. You know we're solving for potential energy, which is mass times gravity times height. We plug those values in. And we're not squaring any of the values. The unit on acceleration is meters per second squared, but we don't have to square any one of our numerical values. So then for this particular problem, not every answer but that one, of course, we're going to multiply 0.6 by 9.8 by 35. And of course I can't put my hands on that number. We should get for potential energy 205.8. And what is the unit of potential energy? Joules. Now I want to do one in the word problem. Excuse me, as the word problems are sometimes a little more cumbersome for us. I've got a 10 kilogram mass. So I know my mass is 10 kilograms, lifted to a height of 2 meters. And I want to know the potential energy. Well, I know that the equation for potential energy is mass times gravity times height. Notice they didn't give you G. So G is a constant. Whenever you're on Earth, you're simply going to use the scenario is on Earth, you're going to use 9.8 meters per second squared because everything accelerates towards the Earth at that rate. I just need to plug in my variables because I've already identified what they are. And here I get 196 joules. Okay, so those are two kinetic energy problems, two potential energy problems. Okay. Now, what I'm going to ask you to do for your assignment today, there are several things actually, so let me go through them with you. I'm going to ask you to fill out the circled items on this worksheet, which you should be able to do based on what I just went over in terms of the variables that are involved in the calculation for each one of the energies. So for kinetic, for potential. So you're doing 1 through 7 and 11 through 16 on this sheet. It's called Worksheet Kinetic and Potential Energy Problems. Then we're going to revisit another of this type of sheet. So here you have some notes on potential and kinetic energy. Let me back out just a little. You'll have some notes on kinetic and potential energy. And then you're going to complete the handout. So here you're matching the unit with the value. So I will tell you that this is momentum, which is something we didn't study. But everything else, power, work and energy, height, velocity, force, you should know. Here you're matching the definition with the term. Here you're determining whether the type of energy demonstrated in the scenario is kinetic or potential. In this series, you're determining which of the objects in the scenario have the greatest amount of potential energy. So you want to think about the three variables that are at play in potential energy, right? So potential energy is dependent on the mass and the height. So, and they're directly proportional. So the more mass an object has, the more potential energy it has. The more height or distance from the ground, the more potential energy. So that's what you're considering here. In this one, you're considering which has more kinetic energy. So potential energy is mass times gravity times height. Kinetic energy is 1/2 mv squared. So mass is directly proportional. The greater the mass, the greater the kinetic energy. Velocity is directly proportional. So the greater the velocity, the greater the kinetic energy. So you're determining between the two situations which has the greater or more kinetic energy. Okay. So we're going to do the top. We are going to do a few of the problems on the bottom. So again, I'm only going to ask you to solve for potential and kinetic energy. You don't have to solve for one of the other variables. So we'll do this problem. We'll do this problem. We'll do this problem, how much potential energy. So if you look at this, you'll notice it wants to know how high. So actually, you can't see that, sorry. It wants to know how high, which means it's looking for height. I'm not going to ask you to solve for that variable. This wants to know kinetic energy. Yep. How much kinetic energy? Yep. Here you're finding mass, so we're going to omit. Omit, they want you to solve for velocity. And this one you're solving for work, which you should be able to do based on last week's work. So you've got the 5 calculations on this sheet, and then just when you thought it was safe, last but not least, you're going to do the problems on this sheet. So you need to show me your work. I want to see the equation written. I want to see the variables listed, and then I want to see your answer. The way that you set up the problem, pardon me, like where you plugged it in the same way that I just did in my example problems. Right, so I listed my variables. I identified my equation, 1/2 mv squared, and I plugged in my numbers and gave an answer. Same is true down here. Now I'm solving for potential energy. Here's my equation. I listed the variables that were given. I plugged them in, gave me an answer. That is how I want you to execute these problems. The other thing that you need to do on these problems is first determine whether the scenario is representative of kinetic or potential energy. And so you serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand with a speed of 30 meters per second. The ball does it have kinetic or potential energy? So determine, then write your equation, list your variables, plug your numbers in, give me an answer. Right? If you send me simply answers, I'm going to send it right back to you tomorrow or the next day and ask you to do it again. Right? So please make sure you show me all of your work. And the point being is that we have to learn the process so that we can actually execute, because I let you slide a little bit, and unfortunately, it came to haunt us on the quiz and test. We're going to omit number 8 because it's asking for mass, and I'm not going to ask you to solve beyond kinetic and potential. Please let me know if you have any questions. I hope everyone has a fantastic day.